Welcome. It's great to have you in our studio. So, can I ask each of you to very briefly, but well, not as brief as I did, introduce yourself, starting with Anton, and then perhaps to tell about Ben a little.
Hello there. I'm a developer advocate at JetBrains, working in Kotlin team, and I have spent about 20 years in Java development. So I have a developer background, but moved to developer advocacy a few years ago.
Cool. And what about
That's it.
Ben?
Well, do you want me to introduce myself? I can do that. Basically, I'm currently the lead architect for instrumentation at New Relic, and I have been involved in development for more years than I care to admit in public. Before New Relic, I co-founded the company jClarity, which was acquired by Microsoft a couple of years ago, and before that, I was chief architect for listed derivatives at Deutsche Bank, and before that at Morgan Stanley. So I've kind of had this career in I guess performance and performance analysis and performance monitoring, which is why it's
Cool. It looks like we share a bit of background with you because I've spent some time at Deutsche Bank as well, and I've spent a lot of time in instrumentation, but I suppose it pales in comparison to the amount of time you did. Cool. And you're going to talk to us about containers and Java. And I know you have you have a lot of customers at New Relic who use all sorts of different versions, and I suppose you really want to encourage them to upgrade. Is it like a painful issue for you? Are you investing a lot of effort to support older versions?
Well, it's not really that we want them to upgrade. I mean, the kind of New Relic ethos is very much the idea that whatever customers have, within reason, we're not going to support, Java 1.2, for example, but within reason, whatever customers have, we'll kind of work with. It's just that we feel, from our own experiences of running, a lot of Java applications in containers, and from what we can observe in our customers' data and what we can see them using, which we're going to talk about a lot in the talk, we have this real sense that there are real benefits to customers to upgrade their Java, to come to Java 11, or at the very least, the latest versions of Java 8. And it will just provide a better experience for them. And the thing about containers, especially containers which increasingly run on one of the major cloud vendors, is that it has a direct cost associated with it. You see, when we used to run inside bare metal in customer data centers, then it kind of didn't matter because it was a capital expenditure, a capex cost. You bought the rack space, you bought the servers, you filled it up with the machine room up with computers, and you kind of bought them. So you'd already invested the cost in them. It didn't matter whether you used them or not. Whereas with the cloud, it's not a capital expenditure, but an operational expenditure. It's moved from capex to opex. So if you have stuff idling in the cloud, you're just wasting money. The cloud and the increasing evolution into containers is an opportunity for many companies to actually do better, to optimize the computers that they need, and in many cases to save quite a bit of money. So that's the story we're kind of promoting with the Upgrade Your Java. Get better results, spend less money, emit less carbon. It's kind of win-win for everybody. I don't want to give my conclusions away too much, but that's kind of the driving point here.
Cool. Yeah, impressive, especially the carbon footprint. With that, I cannot argue at all. I would like to remind one more time to our audience to click this button right here, join the Telegram chat. I know it might be confusing. The button is yellow, but you can join the chat. From this chat, Anton or myself will take questions that you want to ask Ben and ask them right in real time. Well, almost real time. We've got a bit of a lag from the moment when Ben or us say something until the moment that the audience actually hears it. So it might be 10 seconds, but in some bad cases, a job gets stuck or something, it could be even a couple of minutes. So please ask the questions right away. We will check them out, and as soon as there is a good opportunity to ask a question, we will ask it from Ben. And with that, I suggest we start.
Okay, excellent. So welcome to the talk, which is called Why Should Upgrade Your Java and Containers Right Now? And this lovely background slide every year, well, obviously not last year during the pandemic, but every year New Relic folks kind of get together in this lovely place in Oregon, in the United States, which is full of mountains and trees, and so that's why this background exists. And I kind of like it. It's one of my favorite backgrounds to use for my talks. Okay, because I work for a publicly listed US company, I have to show you this slide. And basically what it says is, don't read all the text, but what it says is, nothing I say in this talk, you should make any financial decisions based upon, okay? Because, of securities regulations and things like that. But I hope nobody was going to go out and think, well, we're going to base our entire cloud strategy on one talk that Ben gave today. Right. Okay, so as previously mentioned, I lead architect for instrumentation at New Relic right now, Jay Clarity and Deutsche Bank before that, Morgan Stanley, and then Sporting Bet a long time ago. I'm also kind of known for some of my work in the community. I'm a Java champion, Java 1 Rockstar speaker. I really should update that bullet point because Java 1 hasn't existed for quite a few years now, and I expect some younger people are kind of wondering what's Java 1, which is kind of scary, but there we are. I spent 6 years working on the Java Community Process Executive Committee, which is the body which governs all new Java standards and approves all new JSRs. And that was quite interesting. Seeing the release of Java 8 and Java 9 was quite a illuminating time to be on the committee there. And then also, I live in Barcelona these days, but I used to live in London, and the London Java community has always been a very vibrant place. And while I was there, I helped to organize and also founded, along with Martijn Verberg and a couple other people, the little project you might have heard of called Adopt Openjdk. So we'll talk more about that later on as well. So enough preliminaries, let's get going. What are we going to talk about today? Well, I'm going to take a little bit of time to explain how we got here and what the sort of background for the talk really is. I'm going to introduce New Relic, not because I'm going to do any selling. I'm not. But instead, because what I want to do is I want to explain the architecture, and I've got like one architecture slide which explains how the data comes into New Relic, and then I'm going to use that context to show you some real data that's come out of our customer data set. This is really exciting because this type of data is not normally made available publicly, and so I had to get special permissions from New Relic's legal department. Thank you very much, to allow me to show the data. So this is going to be straight, not survey, not anything. This is going to be the real data about the current state of the Java market as we observe it. And so I'm really excited to be able to show you that data for you today. And then from that, we're going to kind of look at why the technical reasons why Java 11 is better. I'm going to use some of the data that I showed in the previous section to explain some of the things that are going on in the marketplace and areas where people can really do better. So that's going to be the fourth section, yeah. And then I've got a section about Java Flight Recorder. I suppose I should probably call it JDK Flight Recorder now because it's part of OpenJDK, so it can't use Java trademark anymore. So I should probably remember to say JDK Flight Recorder. And that's a major reason why, even if you can't upgrade to 11, you can only come to a latest version of 8. There is still great benefit in doing that upgrade and getting access to the JFR technology. Okay, so let's get started. So how did we get here? Well, let's talk about some history. We'll talk about the release and support model, and then we'll talk about OpenJDK 8 and 11, which are the two main releases we're going to focus on today. So in, I think, just 2 or maybe 3 slides, let's have just the shortest history of Java ever. So here we go, first slide. Sun released Java in 1995 in beta version. And a little piece of history, I think younger people might not know this. This is why JavaScript is called JavaScript. It literally is a pure marketing decision that Netscape made back in 1995. The language that Brendan Eich created was originally called LiveScript. but they changed the name to JavaScript, basically as a marketing deal with Sun. At that time, you couldn't do much with JavaScript except manipulate Java applets, so it kind of makes sense. But it's just, it always makes me smile whenever I think about that and realize that like the two of the biggest languages on the planet today, no technical relationship at all to each other, but just tied together by some tech marketing and some hype. So I always think that's kind of funny. All right, let's skip forward 11 years. There's an awful lot which happens in those intervening 11 years. You know, reflections added, the Java collections libraries are added, generics are added, whole load of things happen. But let's jump straight ahead to 2000 and around to fully open sourcing Java. It literally takes that long. Some components of Java have always been open source, but not everything. And it's only in 2006 that Sun finally finished open sourcing the entire stack that's needed to build Java front to back. Okay, let's jump ahead to 2010. Oracle acquire Sun. They basically, Sun Microsystems run into trouble. Oracle buy them, and they released the first version of Java that's based on the open source code base in 2011. Right, so that's Java 7. So in case you sometimes hear people thinking that there is some technical difference between the Oracle JDK and OpenJDK, that is not true. There have been minor differences, but the main line, like the vast majority, and by saying minor differences I mean things like different fonts. There's very little on the server side which has ever been different from Java 7 onwards until the present day. Okay, so now Oracle own Java. Sun have been absorbed into the huge beast that is Oracle. All right, so let's do the present day. I say the present day, but the present day really includes Java 8, which is now really old. It's kind of what we call a classic long-term support release. It comes out in 2014. It's 7 years old, and now things start to really change as we get into the modern world. There's 3 years between Java 8 and Java 9 coming out. Java 9 changes the release model so that instead of having these long gaps, I mean, you can see the gaps, right? Java 7 to Java 8 is 3 years. Java 8 to Java 9 is 3 years. Now, what happens with Java 9 is that the model changes, and that what is defined are long-term support releases every 3 months. Every 3 years. That's right. And feature releases every 6 months. So the feature releases basically come out on a regular cadence every 6 months, but they are only supported for 6 months. Support them, for free, or if you give them money, they still won't support you on a feature release. Their answer is upgrade. And so what that means is that you have this weird existence of a feature release where it is around for 6 months, then it dies and is immediately replaced by the next one on. Obviously, lots of enterprises don't want to do this, so there are also what Oracle calls long-term support releases, and that's purely an Oracle term, but it's one that the market has adopted, as we'll see. So the LTS releases come out every 3 years. And what's happened is people have decided, well, everyone really likes Java 8. It's where the majority of the market is. So let's just kind of retrospectively make Java 8 the long-term support release as well. Okay, so it was before the model started, but it was retrospectively added as an LTS. Java 11 is the current LTS version. And the expectation, and this is totally up to Oracle, they haven't said any different. And given how unlikely Oracle are to change a roadmap once it's been published, I think it's pretty safe to say that Java 17, which is due out this September, will also be a long-term support release. Okay? So of all the other releases, 9, 10, 12, 13, 14, 15, and 16, they are not LTS. And in fact, of those releases, only Java 16 is still supported. Even Java 15, which came out last September, is no longer supported. You cannot get hold of support from it. You think you might be able to get, as all systems offer what they call medium-term support, you might be able to get that for 15, but certainly not from Oracle, and certainly not for free. So this brings us to the question about what has changed. Well, if you are prepared to pay money, you're prepared to pay a commercial company money for your support for your Java installation, you have a number of options. You can pay Oracle; they will only support you on LTS. You can, as I mentioned, you can pay Azure Systems; they support the LTSs. They also support various medium-term releases as well. Paid support options. But I know the Java market, and not many people want to pay money for support. So the question is, what do you do if you want security and other updates, but you don't want to pay any money? Well, you have two choices. If you don't want to pay money, you can continue to use Oracle's binaries, but you must upgrade every 6 months. So you must upgrade from feature release to feature release, because the previous release stops being supported as soon as the new one comes out. Alternatively, if you don't want to upgrade every 6 months, you go to an alternative OpenJDK vendor, and they are only available on long-term support releases. So that is the story. If you want to be in conformance with the terms of the license and you don't want to pay money, those are your choices, and there aren't any others. So what's the effect of this? What do we think has happened because of the change in this approach? Well, maybe it isn't a surprise, and I'm not giving too much of a spoiler here for the data that I'm going to show you in a minute. But Oracle's Java market share is diminishing, and it's diminishing quite a lot. OpenJDK is gaining greater and greater prominence, and this isn't just one company or one project which is gaining greater prominence. Instead, there are a whole host of new people who are involved in OpenJDK now. The largest one, again, no spoilers, is Eclipse Adoptium. This is the project which used to be called Adopt OpenJDK and is now gathered under the Eclipse Foundation. And Adoptium is a community-led project. It has a bunch of different companies involved in it, and it has, well, in fact, it has some of the other companies that are listed on the slide. It has Red Hat and IBM and Microsoft involved in it as some of the participants. And full disclosure, we're on the steering committee for Eclipse Adoptium as well. And the aim of Adoptium is to provide a vendor-neutral binary and a marketplace and infrastructure to allow other companies who participate in Adoptium to publish their own binaries alongside the mainline Adoptium binary, which is called Temarin. And that's the aim there is really just to provide a vendor-neutral space. So we do produce our own binaries, but we also allow other people to publish them as well. Some of the other names here that I expect lots of people are familiar with: Amazon produced the Corretto build. Microsoft have Microsoft OpenJDK that came out in the last couple of weeks. Red Hat, Azure Systems, and then Alibaba, who produced the Dragonwell binary. And they're obviously a major cloud provider in China, but increasingly are also shipping binaries for use in other parts of the world as well. And they're doing some quite interesting technical work, which in kind of a research mold for Adoptium as well. And then recently, I think it was just the last few days, IBM have announced that they're joining Adoptium, and they will provide binaries which are certified, but which use the OpenJ9 virtual machine rather than Hotspot. All of the other vendors that I'm listing here are all Hotspot-based vendors, but IBM also has OpenJ9. So, as part of this, just a quick note about the new development model. OpenJDK uses mainline development. Features are only merged when they're complete, and so this means the releases can occur on the strict 6-month cadence. No release has been late yet, because the rule is if your feature is not ready, you don't merge. You have to wait until the next release train starts. Now, what this does mean is that the trunk is always releasable. So in a couple of occasions, we have actually had emergency fixes which can be pushed out immediately. So that's a real benefit of the current model, is that you can do these emergency releases if you have to. I think we've had 2 so far in the last 3 years, which has been quite interesting. Of course, what this also means is people about OpenJDK 8 and 11. Well, those projects are no longer run by Oracle. They're now run by community members, by Red Hat and by other folks. Oracle are still producing security patches, and the same patches also appear in OpenJDK. So what happens is Oracle release their binary, which is proprietary and you have to pay money for, with a bunch of security fixes in it. And then as soon as that is public, they will also merge the security patches into the OpenJDK mainline. So this means that other vendors can produce binaries which have the same security fixes and are patched to the same level as the equivalent Oracle binary, which I think is good. You know, it's good that people have agreed on having that level of security consistency between vendors. Now, in terms of ongoing maintenance, what needs to happen? Well, there are housekeeping updates. Things like the Japanese era. The kanji character in Unicode is for a new Japanese era is not known until it's made public. So when the emperor dies or abdicates, a new character has to be published, which means that an out-of-cycle update has to be pushed out. That kind of change obviously wasn't predicted during end-of-lifing of or moving away from Java 8. So these updates have to be rolled into the regular schedule. Things like TLS 1.3. Java 8 is going to be with us for a long time, and so it's very important that we have things like TLS 1.3 available, for applications to upgrade to, so to keep them safe for the long term. Some bug fixes, especially security ones, are also backported to Java 8. There's also potential for some very small features, nothing which changes the semantics or the definition of the Java language specification. The largest feature that's been backported into 8 is Java Flight Recorder, which we'll talk about. So this is the work that the maintainers of Java 8 and Java 11 do. They do this kind of maintenance work to keep the lights on and to keep the platform safe and patched as well as it can. Okay, so that's the background. Java is always that interesting to developers, but it is quite important to understand, how things have changed, because it sets the scene for the data we're going to look at after the next section. Before we do that, I just want to explain a little tiny bit about New Relic for people who don't know that much about it. It's performance monitoring. I would say we're an observability company. We handle billions of customer events per minute. So the data flow that comes in is just huge. Customers send us this enormous fire hose of data, and we handle this in what we call New Relic 1, which is I think the first true observability platform. We have a data pipeline and we have some dashboards, but everything is very configurable and everything is very customizable and programmable. And we're really very open source as well. We recently open sourced $700 million. That was what I spent a big chunk of my last year doing, is opening up $700 million of intellectual property that New Relic has produced. We're a big Java shop. Java is the vast majority of our services, and we're also one of the biggest installations of Apache Kafka anywhere in the world. And we also use the Kotlin language quite extensively. Thank you, Anton. So this is really what our architecture looks like. If you're a Java application, we provide you with a little blue dot, which is a Java agent that you insert into your app. That Java agent sends telemetry data, all details about your transactions and health of your JVM and all kinds of things up to New Relic, which is the blue box. So our core data pipeline takes in data, puts it into Apache Kafka on various topics. We have a proprietary database called NRDB, which is deliberately shaped to handle telemetry data rather than anything else. And then we have microservices and a dashboard, which is completely customizable. So that's the pipeline, that's the architecture. But what this means is we have the ability to aggregate data from our customers. And that data, which they have opted into sending us and allow us to use, we can use it to see trends about the shape of the market. We know pretty well a whole bunch of other things people actually use. This is live data, literally up to the second data, and it is accurately reported from our customers' VMs. We are not relying on people to return a survey. We are not relying on people to tell us what they're using and have to believe them. We know what they're using because it's not the people that have told us, it's their actual production installations. And the data is obviously not perfect because it only comes from New Relic customers. And New Relic customers are not a perfect proxy for the entire Java market. But, so we know that. We know that there are biases in our data. There are biases in every data set. But what we do think, and what analysts have told us, people like Gartner and Redmonk and things, the best estimate that we have is we see data from roughly 1% of all Java VMs, Java SE VMs worldwide. So we see about, the information that I'm going to show you is based on a sample set, a bias sample set potentially, because it is only New Relic customers. I'm going to say that several times. But it's a pretty good data set. And I'm actually really pleased and proud that we're able to share some of the data with you. So let's take a look. So the first question that everyone always wants to know is, which versions are people using? Well, let's see. There we go. As of right now, 62% of the Java market is Java 8. Okay, and that is a huge amount of change that we've seen in just about 6 months. 6 months ago, it was 75 to 80%. So in just 6 months, it's moved. I mean, it's not moving as quickly as Java 8 did when it came out, but we are now very definitely into the phase where we are seeing a lot of people starting to adopt 11 very quickly. And yeah, now you can see why I focus on the LTS releases, because there's Java. And the next largest slice we see is, for some reason, I don't know why, is Java 13. And it is less than 1%. It is 0.68% of the market. And just look at those numbers. I mean, there's barely 1.5% of all the other Java versions put together. Java 7, lots of people if you read Reddit or Hacker News, don't read Hacker News. You can see that they hear people talk all the time about how they're having difficulty getting off Java 7, and lots of people are still stuck on Java 7 and not even on Java 8 yet. Well, maybe, but not in the New Relic customer base. And I have to say that about 9 months ago, the figure for Java 7 was more like 1.5%. But in the last 9 months, I don't know what's happened, because all I see are the very high-level numbers. But Java 7 has been almost completely eradicated. So Java 7 is now just 0.15%. So there we go. That's pretty good news. We've got 35% of Java 11, a number which is still increasing quite rapidly. Java 8 is still the majority, but it's starting to we're going to get to 50-50, I think, maybe as early as the end of this year, which should be great to see. Okay, so the other question people often have is, what about vendors? How much of the market does Oracle still command? Well, let's look. Okay, and here is one of the big bombshells. Oracle is now less than half the market. Oracle is no longer the majority Java provider. According to our data, they now have only 42.83%. So they are still the largest single provider, but they are not the majority anymore. Which I was very taken aback when I saw this. I thought it was going to be a little longer before we actually saw this and saw Oracle lose majority status. But the truth is that adopt Openjdk. This data was before the Adoptium switchover, so it still says adopt Openjdk. I'll probably update the dashboard to say Adoptium. We also have some good rises from Azure, from Red Hat, from Ubuntu. All of the other non-Oracle builds are all increasing their market share. Adopt is just the fastest growing, which is why New Relic got involved with Adopt Openjdk and now with Eclipse Adoptium, because we could see this trend in our data. We could see that our customers were very strongly preferring Adopt over other vendors. So this is kind of interesting, and I'm really intrigued to see what else is going to happen in the market as things mature. Okay, so now let's do something else that we can do, which is to combine, to facet the data, not by just one aspect, not by just the Java versions or the Java vendors, but let's do both at once. Let's see what happens when we do that. Okay, and now for the second big surprise of the day. If you combine the version with the vendor, you get these numbers. Oracle Corporation, 34.49 for their build of Java 8. But the second most popular Java vendor and version combination is Adopt Openjdk with version 11. More people use Java 11 on Adopt Openjdk than they do on Oracle. So as you can see, Oracle's Java 11 is at 7.27%. So it's roughly 2/3 of the size of Adopt on 11. But if you want to use Java 11, what people are using is Adopt Openjdk. So there's a lot of detail in here, but I've got some more interesting things to show you. But I think that this is kind of, if I just flick back to the previous slide, you can just see that 42% was Oracle, and that breaks down. 34% of the market is still using Oracle 8. I can see the detailed data. I don't show it for security reasons, but I can tell you that a lot of that is quite old, quite legacy Java 8 that has not been updated in a long time. Only about 17% of the market is using Oracle's Java 8 and keeping it up to date. So I think that's insightful. A lot of that 34% is just people that haven't upgraded yet. So interesting times. Let's talk about containers. So of all the JVMs we see, we have about 63% of them are containerized. So this gives you some indication of the cloud transition that's going on right now. People talk about how the cloud is taking workloads and people are moving out of data centers and bare metal installations, and that's true. But it's important to realize how far along that curve we are, because we're not all the way there yet. We're only 63% of the way there. There's still 37% of the workloads we see which are not containerized yet. Now that very much might be an artifact in the new Relic data. Do we have customers who are still a lot of slower moving enterprises? We have some folks that are like that for sure. So do the large numbers of JVMs that those big customers have that are still working out their path to cloud, is that skewing this number? It could well be. Could well be. But nevertheless, I think it's an interesting data point. So let's look at the Java versions. And as you can see, it's pretty similar. So the Java versions in containers versus the Java versions outside or in the market as a whole pretty much tracks. We've got the same 61 to 63%. With those numbers are a little bit different to what we had for the general market, but not significantly so. So let's move on from them. Let's look at this slide. Okay, wow, this has got some interesting, because what we're looking at here are two things. On the left, we've got the number of CPUs that people have in containers, and you can see that over half of Java applications run with a single CPU, and that's really bad. When we come into the next section, talk about what you can do and the optimizations you can make. One of the first things that you should do is check that your containers don't run with just a single CPU. Okay, I'll explain why in the next section, but this was a real shock to us, the fact that so many people try to run Java in a container which only has one CPU. If we look across to the right, we can see the MX range. And again, what's absolutely, two things which are quite eye-opening to me. First of all, over 27% of people do not set an XMX range of any kind when running in a container, which means that over a quarter of those VMs, if that's true, that surely means that those VMs are actually vulnerable to a an out-of-memory error, because the XMX can fluctuate as much as it likes, and it will basically see the full size of the container, and then it will go up and crash against the top of the container. So that is a second thing which if you want to make your Java and containers run effectively, that you absolutely must do. It's also worth noting how many containers set tiny XMX sizes. So we're talking about microservices which potentially have very limited CPU, very limited memory requirements. But is that really true? Or is it the case that actually people are trying to force their Java applications into containers which are actually much too small for them? So there's some real glimpses, some ideas here that I think are pretty powerful. Now, there's one other thing which we also need to look at, which is it's not just enough to look at XMX. You also have to look at because that's one of the newer flags which allows you to do something dynamically based on the size of the container rather than a static fixed limit. So in fact, if you take that 8.47%, that actually is part of the not set on this value. So okay, that makes things a small amount better. It's only about 20% of Java containers that run the risk of crashing due to out-of-memory errors and hitting the top of the container limit. Only 1 in 5. Well, that's much better. It's not much better, of course. It's still terrible. So that combination of single core containers and not setting your memory limits is a recipe for disaster in a frightening number of applications that are out there in the wild. Another thing which can also cause issues is the lack of explicitly configured GC threads. Only 6.13% of people configure their GC threads. And again, that is the kind of thing which, depending on your Java version, can come back to bite you later. Next up, let's have a quick look at GC configuration. Now, who actively configures the GC? Well, 68% of people, almost 70% of people don't configure anything at all. They just take the default, which on Java 8 is parallel, and on Java 11 is G1. So that shows us how many people just aren't thinking about the configuration of their containers at all. Over here on the right hand side, we show what type of, because we run the algorithm to figure out what people will actually end up with. And based on the information we collect, we actually can't reliably tell what GC people have 28% of the time. That's basically coming from the bare metal use case, because in the and what we end up with is G1 in 27% of cases, and serial. Yeah, the serial collector is probably the collector which is most likely to actually be detected on a container, because the G1 number is made up of both bare metal and containerized builds, but whereas pretty much all of the serial number here comes from the containerized use case. There are far more people out there running with the serial collector than they realize, and that's almost certainly not what you want. If you're running Java 11 or even Java 8, you don't really want the serial collector to be what you have. So that's data from the market. I hope it was interesting. I hope folks have some questions and have some thoughts about it. I hope it was a little bit provocative. So let's move on. Let's talk about the next section, which is why is 11 better in containers? So why is Java 11 better in containers? Well, I think that for a containerized application, there's really 3 main things in Java 11 that you really want to get the absolute best out of your containerized applications. I'm talking about var, modules, so JPMS, and HTTP2 support. Yeah, I'm joking, of course. Containerized applications may care about some of those things. They certainly don't care about var. But in general, those are not the things that that people are actually going to want to, in their containers. So what is the real reason? Joking aside, I think it's really four things. I think there are four things that help us understand why using 11 is such a good idea. First of all is what I'm going to call container awareness. We're going to talk about that next. Then I've got to say we should talk a little bit about the G1 garbage collector. And then moving on from that, also talk about compact strings, heap reduction, and I'm going to put enhancements in there as well. And then finally, we're going to talk about JDK Flight Recorder. So when you move to containers, if you do this properly, you need to think about a few things. You need to think about GC algorithms and how they're selected. You need to think about memory usage and how it relates to the container size. And you also need to think about CPU utilization and how CPUs are going to be usage. So one of the first questions to kind of get you thinking about this in the right way is, if you have a Java program that calls runtime.getAvailableProcessors, what does it return? If you run that in a container, what do you get back? And the answer is, it depends. It depends. In very old versions of Java 8, for example, it won't see the container at all. So if you are running a single core container on an 8-core underlying bare metal host, on an old version of Java 8, if you call runtime.getAvailableProcessors, you will get 8, not 1, as the number of available processors. Now that's a problem, because what will happen is, for example, the number of garbage collection threads that get created. Let's suppose you're running an old version of Java 8, so the default collector is parallel. The VM sees 8 available processors because it doesn't see the container. And now you have 8 GC threads. So when a parallel full stop the world GC kicks off, you will have 8 threads contending over a single CPU where they will actually be scheduled. So your garbage collection performance on that old version of Java 8 will be absolutely terrible. Hopefully, I hope, not too many people are running those old versions. But if you're below 8 update 131, that's the behavior you'll see. So this kind of leads us on to how do we even select a GC? Well, you may have heard the phrase GC ergonomics, and that phrase, I don't know, a long time. I certainly first started hearing it in round about the Java 5 timeframe. And what it really means is that the behavior of the GC and even how it's selected depends upon the runtime environment and also how the GC is behaving. So the sizing of the memory pools depends upon the observed behavior of the GC. But for selection, it depends upon really 3 things. I'm slightly hesitant. I think I might have missed off 1 or 2 factors that could actually play a role in the selection of the GC. But it certainly depends upon the Java version, the server or client class determination, as it's sometimes called. If you're old like me, you may have been around to see switches called -server and -client. And when we talk about the class determination of the VM, that's what we're talking about. And related to that is the CPU count. And the fact that this is so complicated is really one of my I guess my real concerns about modern Java for the cloud. People who are just starting out, new developers who are new to programming, they don't know about this complexity, and they shouldn't have to. They shouldn't have to know, about all of the details of this. They put a Go application into a single core container, and they don't do any tuning of it, and they give it, tiny amounts of memory, and it works fine. Actually, the GC in Go suffers from some of the same problems that I'm going to describe, but that's another story. They do it with Python. Python is fine, needs no configuration. So I think it's unrealistic of us in the Java world to have all this complexity going on and not be able to give a clear story to people who just want to run their application in a container. And that, I think, is why, I don't have any evidence for this, but I think that is why we see so many badly misconfigured containers. It's an education problem, and as the people in the Java community, we have to do a better job of this. We have to do a better job of explaining how and to default to sensible things in a containerized environment. I'm going to show you a real quick bit of C++ code, so don't get scared. But this is actually the block of code in the Openjdk code base that actually selects the GC. So if you specify a GC flag and that GC is not compiled into the VM, it will fail. If nothing is selected, it will select ergonomically. And that basically is it. So it delegates down to this process of using the Java version, the server and client, and the CPU count if nothing is specified. Okay, so that's the first thing. So there is a process for determining the GC algorithm, and critically, if the CPU count is 1, you are going to probably end up with the serial collector, which is almost certainly not what we wanted. So serial is a very real danger here. What also complicates things is, what is the maximum heap size if you haven't detected anything? And by default, if you're on a bare metal server, you get a quarter of the physical memory in the box. And you can test this from the command line. If you have a Windows, a Linux or a Mac-based machine, I don't know about for Windows, but you can do this type of thing. You can just say Java -XX print flags final minus version, and then grep for the max heap size. And that will show you what maximum heap size is actually detected. You have to parse the number in a little bit, as that's in bytes. But if you work it out, you can probably squint at it and see that it's about 4 billion. So it's actually 4 gigabytes. So this was done on a 16 gig physical laptop. And so the max heap size that's actually detected is a quarter of the physical memory. In a container, well, like all good things in software, it depends. It depends. Early versions of 8 counts. By the time you get up to update 191, it improves the situation somewhat. But crucially, the updates which have happened in 11 have not been backported. The detection of heap size and of GC in 8U191 is as good as it's going to get. It will never get any better than that. And that's a problem, because in a container, memory consists of Java heap memory, off heap, memory for auxiliary processors. And not setting the heap memory size leaves us open to this with 20% of containers in that situation. In general, Java 8 is not as well suited for deploying containers as Java 11. So for people who know a bit about how containers work, you're probably aware of a thing called the cgroups. And the cgroups basically is how you partition resources within a containerized environment and share out the bare metals, memory and CPUs. So 131 and before, no use of cgroups at all. Between 8U131 and 191, there's a fixed approximation. And then at 191, you get the full support backported that is going to be backported. So this is why the not setting the GC threads numbers exactly is a bad idea, because you're using this well, either no approximation at all or a quite crude approximation to how many CPU shares are actually present. And the two places where this comes up are the GC threads and the number of threads for VM-sized, VM-managed thread pools. Now, this is the thread pool that's used by a lot of internal operations within the VM, notably things like the parallel streams uses a VM-sized thread pool. Lots and lots of other things in the libraries rely on a sized thread pool for them. And if the VM numbers are not correct, you won't get the right size pools. So my advice is very much to consider explicitly setting the flags to size those to the exact numbers. So after all that bad news, here's a cute picture of a cat, and let's talk about G1 and why G1 at Java 11 is better. For those folks that don't know much about G1, it's the garbage first collection. That's literally what G1 stands for, garbage first. I have been using it and working with it since it was in the 7 betas. So when I was at Deutsche Bank, I did experiments into what we thought of at the time as low latency trading. I was in the FX group, so we were interested in performance. So I experimented back when I could still crash the JVM by using G1. So it was released as an experimental collector in Java 7. Oracle made the decision to support it in Java 8, but then they did a lot of work on it between Java 8 and Java 8 Update 40, which is the first version of G1 that I consider to be production quality. It's quite different before that. They made it default in Java 9, and it is vastly improved by the time Java 11 comes along. I always tell teams that if they're using G1, because you can obviously use it in Java 8 and opt in. If you opt into using it in Java 8, then you should consider moving to 11 just to get advantage of the new version of G1. What's interesting about it, or at least I think this is interesting, is that it was intended to be low pause. It was intended to be a replacement for the concurrent mark and sweep collector, CMS. But it didn't work out that way. Instead, G1 has ended up as a general purpose collector. It's ended up as a replacement for parallel rather than CMS, because it just, life took a different turn. And why is that important? Well, that's because there are trade-offs between collectors. There are different parts of the performance space. A collector which is well optimized for throughput and for efficiency and low cost of garbage collection performance. Low cost is not the same as low pause. A low pause collector may have to use significantly more CPU and significantly more time overall to do its work, but it benefits with low pause in terms of stop the world pause. Whereas the parallel collector is incredibly efficient, like so much more efficient than any of the concurrent collectors, but it does have that potentially long stop the world pause. And the real problem of the parallel collector is that its pause time is linear in the size of the heap. And that means that if you want to do larger and larger heaps, you have a problem, because you have to stop for longer and longer. So if you have a 200 gigabyte heap, you could be stopping for 30, 40 seconds. And for lots of applications, that's just not feasible. So the design of aims of G1 were to scale to larger heaps, to have control of the pause time, and to make it easy to tune and to make it predictable. The real difference between parallel and G1 is that parallel leaves you with a perfectly tidy heap. All the work is done, the heap is spotless, all of the objects are grouped up together at the start of the old generation, and the rest of the old generation is empty. It's perfectly pristine. G1 never gets into a pristine state. Like G1 is like having a live-in cleaner. Depending on how much mess you're making, they're working while you're working, so you're making mess, but they're working to tidy up behind you. Does the house ever get perfectly tidy? No, it doesn't. But as long as you're not making mess faster than the cleaner can clean up, it never gets completely overwhelmed and completely dirty either. So that's the difference in philosophy. That's how G1 is able to have, to not stop the world pause time, but instead can keep going with a short pause time, even to larger and larger heaps. What you've given up is the idea that at any point, the heap will ever be perfectly tidy. So if you want some buzzwords to describe what G1 is and what it does, I think these are pretty accurate. It's a parallel collector. It uses multiple threads. It's a concurrent collector. It runs at the same time as application threads do. And it's what I like to think of as a statistically compacting collector. It doesn't do everything, but it just kind of tidies up a bit as you go along. Uses regions, and it allows the partial cleaning. That's how it works. It's still generational, but the generations, as you can see, are not confined to be next to each other. The generations are all spread out. There's a bit of detail in here about remembered sets. Basically, you need to have a pointer. If you have an object in one region which points to an object in another, you need to track those pointers. And this is where G1 actually adds some additional work. Because in the parallel collector in Java 8, all the work is done by the collector. Virtually no work at all are done by the application threads. The application threads just update their pointers, and that's pretty much it, apart from these things called card tables, which are very, very cheap. The collector does almost all the work in parallel. In G1, the work is a little bit more balanced. So this means that this can actually interfere with application throughput. When you move from Java 8 to Java 11, and you don't, if you're on the default collector on 8 and you're on the default collector on 11, you will see a potential slight drop in application throughput. So there is some bad news. There is some trade-offs here. In general, though, G1 and 11 is significantly better, and I think that overall, all the apps that I've seen, the vast majority of apps that I've seen migrate to Java 11 and pick up G1 actually do better from it overall. But it's a better pause time performance. You have better predictability. Overall, you may see a slight increase in CPU utilization. And certainly the throughput is slightly lower for G1 because more work is being done on the application thread to benefit GC. So that's one thing that I have observed when people upgrade from 8 to 11 is they sometimes come to me and say, "Hey Ben, I'm looking at the new Relic CPU utilization graph, and we're burning more CPU on Java 11." And I'm like, "Yeah, that's probably true. You probably are." But the question is not, are you burning more CPU, but is it significant? And is it worth it overall? And in those cases, I think the answer is very much yes. So I think I've pretty much just said everything on this slide. So G1 is concurrent GC, parallel sort of world, and you use more CPU in exchange for shorter pause times, more consistency, and it being easier to tune. Another major improvement in Java 11 is compact strings. So you probably know this, but before Java 9, strings are chars. Array of char, that's what backs a string. And chars are 2 bytes per character. That's actually the UTF-16 representation. So it's not really 2 bytes per char, it's actually 2 or more bytes per char. But UTF-16 very rarely uses a third or fourth byte. Now, for a Western European language, this means you're going to waste 50% of storage. For folks that deal with Cyrillic a lot, this advice may not apply to you as much. But for Western European languages, the first byte of any char is pretty much always 0. So in Java 9, you can actually have a per string choice. And it automatically detects how a string is to be encoded. Is this a Latin 1 string? So, English, Spanish, French, languages like that. Or is it UTF-16? And it's actually Latin 1. The internal representation will be bytes. I mean, in fact, it's bytes in both cases. But in the Latin 1 case, you only need half the bytes because you don't store the 0 byte. So in a very common case, this saves a lot of space. And you just have this. This is actually from the JDK source code. You can see that it says it's got the value is now byte rather than char, and you have these encodings. I'd be interested to see from folks that do Russian applications how much space this saves. I don't think it's going to save as much space as it does for things which only deal with English and Western languages. In the cases we see at New Relic, for our own internal data, we see 30 to 40% heap improvements. So the heap size can drop by 40%, And what that means is, in some cases, we can even use smaller VMs. So our savings, this is an example of a direct cost saving, because if your heaps are smaller and you can fit into a smaller instance, well, if you fit into a smaller instance, you just cut your bill in half, because you don't have to pay for instances which have a lot more memory. Okay, so how are we doing? We've got about 5-6 minutes, so because I want to leave some time for questions. So let's talk about Java Flight Recorder. JDK Flight Recorder, as I must learn to call it. So this is kind of cool. It's a profiling tool which gathers diagnostics and profiling data. You may have gone to the Datadog talk before this one, so I'll try to be brief. It's kind of interesting. Originally, you see, I have to remember to say JDK Flight Recorder now. Before that, it was called Java Flight Recorder, but that wasn't its original name either. Back in the day, when it was first created, it was actually called JRocket Flight Recorder. It goes all the way back that far, yes, and it was part of the BEA tech stack that was acquired by Oracle. And then when Oracle also acquired Sun, they made the decision to bring JRocket Flight Recorder into Hotspot. It's been around for a long time. It's very mature. It works really well, and it's now finally been open source. So it was open source into Java 11 as for the first version, and there has been a backport by Alibaba and Azul and a few other people, which has been merged into the main line of OpenJDK. So if you're on 8U262 and upwards, you too can have Java Flight Recorder. It's a very low overhead profiler. Oracle claim about 1% to steady state impact. I think based on a useful data profile, because you can actually configure which data points you want JFR to collect, on something which is useful to our customers, I think the overhead is around about 3%, which is is still very, very good. Some other profilers, some commercially available profilers, in the wild, we would actually expect to see about 15%. And I know that one of our competitors has a profiler which regularly does 15 to 20% performance impact on a running system. So to have something freely available, open source, which only does 3%, we think is a huge step forward. There's a fantastic GUI console available for it called Mission Control, JMC. You can start it up from the command line by saying, I want to start a recording at startup, but that can be very challenging to work with in containers. It comes with a command called jcommand, or some switches in jcommand where you can tell it to control the Java Flight Recorder recordings. But the problem is that this is not very useful on a container, because not many people want to SSH into their container and run commands in order to control the recordings. Here's what the mission control screens look like. You can see here like some overview stuff, allocation. So this is allocation of new objects, and some method profiling. Now, some of the best practices we have at New Relic that we've developed are to set JFR up in what we call in a ring buffer configuration. So this holds later. So all of the events for the last 2 hours are just in memory, and as the application runs, it overwrites older events. So just a standard ring buffer idea. And then you can use jcommand to go in and dump the file as required. Now we can SSH into our containers, but lots of people don't like that. But if you do follow this pattern, it kind of allows you to go back in time. Because if you have an incident, providing the container hasn't crashed and the VM is still running, you can log into the container, run a jcommand, and dump the file. And then you can go back in time and see the effect of what happened when the incident started. So that was our original approach to this for our own internal use. And it's not ideal. You need an SSHD. It's not very automated. It's very manual. So instead, we came up with something new, which is what we call real-time profiling. So we have an open source piece of Java code, which is actually you can install as a Java agent, or you can even dynamically attach it, or you can run it as an out-of-process JMX daemon if you don't like running Java agents. And what this does is this basically collects JFR data and sends it up into New Relic. So we can build some screens like this one, which just shows you your cluster performance over time. And you've got a timeline here where you can see what was happening on a bunch of machines in your cluster at different times with a heat map to show you what you can access. From that we can just kind of build some flame graphs. So that's an execution flame graph at the top there. Various other bits of basic telemetry that we can get out of JFR. So I'm actually just going to switch to my IDE and just show you a couple of bits of code just because it's fun. We haven't seen any code and haven't done any IDE, so we might as well. So here we have a couple of the classes. This is all open source. It's all up on GitHub. So new Relic -jfr-core. If you want to build the code and have a play with it, feel free. And here is our out-of-process daemon. So we build a config. We connect over JMX, and then from that, we basically build our controller. And the controller is responsible for collecting JFR recordings, transforming them into an event stream, and sending them up to New Relic. So we have an open telemetry format that we use. It's not the open telemetry OTLP format yet. We're working towards that, but we're not there yet. But what we're actually building is just an open documented protocol for speaking JFR. And what we represent the JFR events. We transform them into an open JSON format, which is all documented in the project. And then we also have this as a Java agent. So we use the standard Java instrumentation approach where you have a pre-main method. We basically check to make sure that the JFR APIs are present in the VM, because not every version of Java 8 has them. And because we support Java 8 and 11, we have to reflectively check to see whether the appropriate API is in place. So we do that before we do anything in the agent. And yeah, so that's the agent version. And then down in the depths of this, I'll show one more bit of code, and then I think we'll open it up to questions in a sec. We actually have transformation events down in here. So we do things like, zoom in a bit. We pick up a JFR event and we transform it. And we pull out the incoming thread CPU load so that we can basically detect the user and system load from individual threads running within your JVM, so that we can display that. We turn this into an event, send it up, and it appears in the UI. Okay, I know that we're about out of time, and I'm sure people have questions. So let me just skip through the last slides. There's a huge pivot coming towards open instrumentation. We want to make sure that JFR can be bridged to open tools and other open source tools, such as OpenTelemetry. But it is a major advantage of moving to Java 11. And we feel like running in a container, you really need to have proper observability and proper monitoring. And JFR should be a big part of that story for all Java developers. I'm constantly amazed by how much cool and interesting and useful stuff there is. Didn't have any time to talk about JLink and GraalVM. Obviously, there are further frontiers for fast startup, and there's some challenges as well, things like modularization and the closed world assumption. But I think if you ask me what I might be talking about in a year's time, I think JLink and GraalVM and Quarkus might well be part of that. So the conclusions: upgrade to Java 11, size your container correctly, don't use single core containers, explicitly choose your memory and GC flags, use a concurrent GC, do not use serial, and enable JFR. And with that, I think we're done. Thank you. On the screen is my email address if you want to send me any follow-up questions or just have a conversation with me, and a couple of my most recent books.
Cool. Thank you so much. We do have a bit of a question in the chat. I guess I can say it out loud. So the question is, hold on a sec. Maybe Anton, can you take it? I'm not sure if I understand it, and you seem like you did. You are muted. Muted, you are muted.
Is it this one? Is it take out the box, put in commands, and except some cases in Java you have to think about it?
Yeah,
is that the
exactly.
question? Yeah, okay. Yeah, so this is the thing is it's a difference in worldview, and it's also a difference in age. You know, Java comes from a long time ago. It's a mature language, and it's very much from the era when people had bare metal servers. And it's very smart and it's very sophisticated. And it does a lot of work to work well in a bare metal environment. And whereas Go, I think because it's more modern. I don't like the word modern. It's a younger language. It doesn't have the same history as Java because it didn't have to live through that era and learn from the things which happened. It's actually the case that Go does have some of the same problems because Go's GC is actually a concurrent GC. And if you put it in a single core container, well, there's only one thread. So it's not actually a concurrent GC anymore. Because if you have only a single core, there's only one place to run. So running concurrent GC in a single core container is not going to give you very good performance. But I think for some reason, people just don't see the same problems. I think that because Go doesn't do things like as complex an adaptive sizing of heap, for example. So I guess it's a trade-off. I think we could, as a Java community, do a much better job of explaining the issues and making it easier for people. But at the same time, I also think that the other languages also have problems which are probably not as well recognized as the ones we have in Java.
Indeed. All right, then thank you so much for your talk. It's been great to have you, and I invite you, Anton, and all the audience to the discussion zone. You can click on the button below and have a nice chat with all the people that come there. Thank you so much.